Okay, so I want to try to do 3 problems on your homework assignments to get you comfortable with navigating my math lab. So we have to graph this solution, this system, and its inequalities. So I have many different ordered pairs. They're both lines. Notice one of them is or equal to, so this is going to be a dashed line. One of them is just strictly greater than, so this is going to be, oh, sorry, I think I said the wrong word. This is or equal to, so this will be solid. Solid. And this is greater than, so this will be dashed. Remember, if it's dashed, ordered pairs that are on the line are not solutions. So I got some graphing to do. And the best way, I could solve for y here, but you could also just find the intercepts, which might be easier here, because 2 and 5 both go into 10 nicely. If I let x equal 0, I could solve for y. Y would have to be -2. And that's the y-intercept. If x is 0, y is -2. So my line is going through 0, -2. Now, if y is 0, then x would be 5, because 2 times 5 gives me 10. So if y is 0, x is 5. And that's the ordered pair 5, 0. So I'm drawing my line at 0, 2, I'm sorry, 0, -2 to 5, 0. 0, -2 to 5, 0. And if you hover over here, do you see how the ordered pairs are changing? And if you made a little mistake, let's say you did this to 0, 5, or 5, 0, keep on messing that up. You can change this. So you click on this ordered pair right here, and it says edit coordinates. You don't want -1, -1. You wanted this to be 0, -2. So you press edit coordinates, and you can change this to 0, -2. And then this ordered pair, oh, it was perfect. 5, 0. Okay, so that's good. Now, do I want it to be dashed or solid? Well, I want it to be solid because it's or equal to. If you click on this, it makes it dashed. But then the filling in, the shading, I'm going to say that to the very end because, well, because I need to shade the solutions that are satisfy both inequalities. Right now, what would I shade? Would I shade above or below? Well, it's not too clear, but notice that the ordered pair 0, 0 is above this line. So if I type in 0 for x and 0 for y, I get 0 minus 0, which is less than 10. So letting x equal 0 and letting y equal 0 is a true statement because 0 is less than 10. So that tells me that related to this line right here, I'm shading above. So all the ordered pairs above here are a solution to this. But I also need to find the ordered pairs that are a solution to this. And the solution to the system is all the ordered pairs that are on both inequalities. So now it's time to graph this second one. So I grab my line graph and I use my intercepts again. If x is 0, y would have to be -4 because -2 times -4 is +8. So 0, comma, -4. And then if y is 0, x would have to be 2. All right, now this one is dashed because it's just greater than. Now, where do I fill in? I've got 4 sections. Here, 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 or this section. Well, we already know, remember the solid line? It has to be above the solid line. So the question is it in the upper left or in the upper right? It all depends on this. Notice 0, 0 is to the left of this line. And I picked 0, 0 because that's the easiest order pair to test. If x is 0 and if y is 0, you have 0 minus 0, which is 0. Now, is 0 greater than 8? Of course not. 0 is less than 8. So 0, 0 is not a solution to the dashed inequality. So therefore, it must be this section right here. And I press save, and I press submit, and it congratulates me. Let's see what this one looks like. What's that though? Here's what I wanted to do. I've got 4 inequalities. So x is greater than 0, y is greater than 0. So I got a lot of work here, but they're all lines. First of all, starting with x is greater than 0. Well, x is a vertical line. So x equals 0. All the ordered pairs where x equals 0 would be the y-axis. It's this line. And notice the x is greater than. So when x is greater than, it's very simply to the right. So all these ordered pairs over here are solutions to just that first part. But then I got another part. Y is greater than 0. Well, I had to graph the line y equals 0, and all the ordered pairs where y equals 0 is right here, which is also called the x-axis. And if the y value is greater than 0, then I'm shading above that. So by graphing the first 2 inequalities, I'm in the first quadrant. Now I've got 2 lines to graph, and they're both will be used for y, finding the intercepts. You could solve for y and graph that way, but I'm going to do the intercepts. So when y is 0, the x would have to be 2, because 6 times 2 is 12. So that's the ordered pair 2, 0. When x is 0, y would have to be 6, because 2 times 6 is 12. So that's 0, 6. So that is that line right there. And then the other line, this would be 5 times 3 gives me 15, and 3 times 5 gives me 15. So when x is 5, 0, and when y, okay, so I made a mistake. So this is perfect. Now I get to correct this. Here, y needs to be 5, x needs to be 3, because 5 times 3 is 15. So I'm going to change this to 3, 0. And the other ordered pair, I want it to be 0, 5. And that's exactly as I want it. And they're all solid because they all have that or equal to sign. Now, where do I shade? There's only 4 real regions I need to consider, because remember, my x equals 0 and y equals 0 put me in the first quadrant right here. So let's see, the 6x plus 2y equals 12. That was this blue line on the bottom right here. Is 0, 0 a solution to that? If I type in 0 for x and 0 for y, 0 plus 0 is less than 12. So yes, I would shade to the left of this line over here. And then the other one, 0, 0, is also a solution to this last line that I graphed, this one. If x equals 0 and y equals 0, I have a true statement. So it has to be, 4 things have to be satisfied. I have to be above this line. I have to be to the right of this line. I have to be under this line, so like down and to the left of that line, and under this line, down and to the left of that line. So that's 4 different shadings, and where they all overlap is right there. They all overlap right here. So that is our solution. And we'll end with this one. So I've got x is less than 7. So all the ordered pairs where x equals 7 is right here. And it's not dashed, it's solid because I have the equal to part. Now when x is less than 7, it's everything to the left of it. The other inequality is y is greater than or equal to -5. Well, when y equals -5, it's this horizontal line. Every ordered pair on here, the y value is -5. And I want to be I want the y values to equal -5, but also be greater than -5. So if I'm on the line, the y equals -5, and everything above the line, the y values are greater than -5. So where do I shade so that my x's are less than 7, but my y's are greater than -5? Is this big section right here. So every ordered pair on here satisfies the whole system. Every ordered pair on here, the x is less than 7, and the y is greater than or equal to -5. And of course, if you could clear it all out if you really want to start over and press on the arrow. I couldn't find the save button, so you press on the arrow and then it allows you to save, and then you're done. So good luck. Please email if you have any questions.